This is the homework for 181, 182, 183, and 184. Before we rewrite each expression, I want to talk about how you get a negative, or what a negative exponent actually means. So 3 to the third power is 3 times 3, which is 9, times 3 is 27. 3 squared is 9, 3 to the first power is 3, and 3 to the 0 power is 1. And how do you get 1 for 3 to the 0 power? Well, if you look at the pattern, 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. And if we continue that pattern, what does a negative exponent represent? Well, 3 to the negative first is an equal 1/3. Because we keep dividing, we follow that pattern, 1 divided by 3 is 1/3. And if we keep following that pattern, 1/3 divided by 3 would give us 1/9, which is 3 to the negative second. So if you have a negative exponent, bring it down to the denominator, and it'll give you, I'll make it positive, but you have to understand why if you bring it down to the denominator. And 3 to the negative second equals 1/9, and that could look like this. Bring that negative exponent, that term, down to the denominator, it'll make it positive. And you can see why it does that. And we continue, 3 to the negative third is 1/27. So for 181, 4 to the negative first, we bring down that into the denominator. 4 to the first is 4, so we get 1/4. For B, 7 to the 0 power, anything to the 0 power equals 1. For C, we have a negative exponent. We bring it down to the denominator. 5 squared equals 25, so it's 1/25. If you were to have a negative exponent in the denominator, you would bring it up to the numerator and then simplify. For D, x to the negative second power. Doesn't matter if it's a variable, an integer, doesn't matter what it is, you still apply the same rule. If it's a negative exponent in the numerator, bring it down to the denominator, and it's 1 divided by x squared. For 182, we need to determine the inputs for the following functions with the given outputs. So we don't have the input. We need to determine the input, but we're given the output. In previous math classes, f of x would be y, and we would be solving for y, or we would be given the value of y and solving for x. So y equals -1. So there's no difference. F of x equals -1. So for f of x, we know what that equals. So we're going to make it -1. So f of x equals -1. Now we're going to go ahead and solve for x, our input. Inverse property of subtraction is addition. We're going to add 7 to both sides. This creates a 0 pair. We have more positives than negatives, so we know it's going to be a positive. Signs are opposite, we subtract. 7 minus 1 is 6. Now we have multiplication. Inverse of multiplication is division. Here we created the giant 1. We're going to divide both sides by 3. 6 divided by 3 is 2. So x equals 2. For B, we have f of x equals 10. We have the output. We need to find the input. So we have f of x equals the square root of 2x minus 6. So we know what f of x equals. So instead of f of x, we're going to substitute it with 10. Now we're going to go ahead and solve for x. And here we have the radical sign. And the inverse of taking the square root is squaring. So these will actually cancel out. They undo each other. They're inverse operations. But what you do to one side, you need to do to the other. So if I'm going to square the right, I'm going to square the left. So now that gets rid of the radical sign, and 10 squared equals 100. Still not have x by itself. Now we're going to add 6 to both sides, created a 0 pair. 100 plus 6 is 106. And now we have division. Well, we have multiplication, but the inverse is division. Created the giant 1. What you do to one side, you do to the other. 106 divided by 2 equals 53. And the proper way of writing it, because we're solving for the input, x equals 53. For 183, you need to determine if the graph represents a function and then state the domain and range. So first we're to determine if this graph is a function. And I'm going to use the vertical line test. The vertical line test, if at any point my pencil, this vertical line, touches more than one point at the same time, it's not a function. And it doesn't. For each input, there's only one output. So at any time, my pencil is only intersecting the graph once at a time. So this graph is a function, since there's exactly one output for each input, and it passes the vertical line test. Now to determine the domain and range, remember the domain are all the possible x values, and the range are all the possible y values. And if we look, this graph is going forever in this direction, and we continue it to the positives, and it's going forever in this direction. So our domain are all real numbers. Any real number will be on this graph. Negative numbers and positive numbers. Now our range is different because our range has limits. And here's our origin. If we go +1, +2, +3, our greatest range value is +3. And our least range value is +1. So if we were to write that, our range, our y values, are greater than or equal to 1. They're greater than this, but less than or equal to 3. Those are all our possible y values. For b, we're going to determine if it's a function. And I'm going to go ahead and do the vertical line test. And at no point are there multiple outputs for my input. So it only touches the graph once as I go across. So this graph is a function, since it's exactly one output for each input, and it also passes the vertical line test. Now let's determine the domain and range. The domain is all the x values, all the possible x values, so on the x-axis. And if we look, this line is going to go forever in the negative, towards the negative numbers. This line's going to go forever towards the positive numbers. So the domain is all real numbers. Now let's determine the range. The range are the y values. And if we look at the y values on the y-axis here, you can see there are no negative numbers. It starts at 0, but our y values are going to continue up forever, infinitely. So our range is our y values, or y is greater than or equal to 0. Because it's not going to be less than 0, it's going to be greater than 0. For C, let's determine if it is a function or not a function, and we can start by using the vertical line test. And as I do bring my vertical line or my pencil across, you can see that for each input, so here's +1, my input is +1, I have multiple outputs. So this is not a function. It did not pass the vertical line test. So this graph is not a function since there are multiple outputs for the same input. It does not pass the vertical line test. Now let's determine what the domain and range is. So the domain are all the x values. Look on the x-axis, and you can see as I go, -1, -2, -3, well, this graph doesn't include -3. It starts here at -2. And it goes infinitely to the right, towards the positive numbers. So our domain, our x values are going to be greater than or equal to -2. Our range are all the possible y values. And if you look, it's going to go infinitely in this direction towards the positive y's. It's going in an upward direction. And this one's going in a downward direction towards the negative values. So the range, all the y values, are all real numbers because it's going to be all the positive numbers and all the negative numbers. For 194, we're going to write each number in scientific notation. So let's do a review of scientific notation. So a number is written in scientific notation when a multiplied by 10 to the n, the power. So when it's written in this form. So an n is an integer. So integers are positive whole numbers and their opposites for 0, 1, 2, 3, 4, 5, and their opposites -1, -2, -3, and so forth. So here, a, this term, has to be greater than or equal to 1, but less than 10. So it's easier to show you an example of that. So let's look at problem A. So we have 160 million. We want to write this in this form, scientific notation. So what we need to do is we need this A term to be greater than or equal to 1, but less than 10. So I'm going to decrease the value. Here's the decimal. And we're going to decrease it 8 place values. 1, 2, 3, 4, 5, 6, 7, 8. And that's where I'm going to place my decimal. So if you look, this A term is greater than or equal to 1, but less than 10. And I'm going to multiply it by 10 to the 8th power. Because what I did is each place value I moved the decimal, I'm dividing it by 10. Well, an exponent would be multiplying it by a 10. So it's 10 to the 8th power. So, and one way to look at it to make sure you move the decimal the right way is I have a very large value that I turned into a very small value, but I'm multiplying it by 10 to the 8th, which is a very large value. For B, I have 58,413,000,000. We want to put it in scientific notation, so here's the decimal. I need the A term to be greater than or equal to 1, but less than 10, so I need to move it over to here, and I'm going to count the place values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to give me 5 and 8,413 10,000ths multiplied by 10 to the 10th power. And this exponent is how many place values I moved it to get this term, the A term, greater than or equal to 1 but less than 10. If I wanted to put it back into standard form, I would just increase move the decimal to the right 10 places.